Okay. This is 8-5, angles of elevation and depression. Talked a little bit about angles of elevation and depression in class yesterday when we were doing our project, but this is your official lesson over them. An angle of elevation is formed by a horizontal line and is the angle that's measured up. So if you're going upward from a horizontal line, the bottom part of the angle is horizontal. Okay, so it's like you're on the ground looking up. Okay. An angle of depression looks like this. Okay, it's from a horizontal line and the angle is measured down from the horizontal. So the top part of the angle is horizontal. And it's like you're from above looking down. Now that terminology is really important because every year I have kids draw their pictures wrong. Okay? You're not always going to be given a picture for the problems today. Sometimes they're going to describe something to you and you're going to have to draw it. For example, if I am in Wrigley Field, Chicago Cubs, and I'm on the Green Monster wall. I've got seats right on top of the Green Monster wall. So here I am, and I'm on top of the Green Monster. Okay, and let's say one of the Chicago Cubs players is out in left field. Okay, and somehow I have some kind of measuring device that measures that the angle of depression from me to the baseball player is 23 degrees. So it tells you that the angle of depression is 28 degrees. Okay, the Green Mile, I don't know how tall the Green Mile is, I don't remember, but we're going to say it's 50 feet. Let's say the Green Mile we know is 50 feet tall. And we want to know how far are we away from this Major League Baseball player. I have a lot of people draw their picture like this. Okay, they only do it on angles of depression. Usually the problems that talk about angles of elevation, people don't have a problem with that. But angles of depression throw people off because they want to tell me that the angle of depression is right here. Now let's go back to our definition of angle of depression. Is the top part of my angle horizontal? This is the top part of my angle. Is it a horizontal line? No. You have to imagine a horizontal line from your line of sight going out. Okay, there's nothing really there but air, but you have to imagine that horizontal line, and this is my angle. Okay, now I just did this part on scratch paper. You don't have to put it in your notes if you don't want to, but I just wanted to show you that. Alright, so let's look at some examples. Okay, this example is on page 446 if you want to actually read it, but I'm just going to kind of describe it verbally to you. Okay, and this is the quick check number 3. It should be underneath one of the examples. Alright, so if you want to read the storyline behind it, basically it's an airplane that's flying across the water and there's somebody in a raft. Okay, so we're going to draw an airplane. By the way, this is my absolute favorite section of the whole year because I like to draw the little figures. Alright, there's my little airplane. Okay, and there's my water. And here's Tom Hanks. Okay, what was that movie, Castaway? I don't know if y'all watched that or not. I'm showing my age. Tom Hanks, Castaway, with the ball that he named Wilson? No? Okay. Y'all have to watch Castaway. Anyway, there's Tom Hanks, Castaway. Okay, it says that the altitude of the plane is 3 kilometers. Altitude is how high the plane is in the air. So when I say altitude, I'm talking about this distance right there. Okay, and it's 3 kilometers. Okay, The plane needs to know how far away he is from the person in distress. So this is the distance that we're asked to find. Always put an X on the part where they're asking you to find something. And it tells you that the angle of elevation, or the angle of depression, is 26. So here's the line from the airplane to the person. Am I going to put the 26 there? No. Remember, imagine that horizontal line going straight. This is going to be the angle of depression. That's your 26 degrees. Okay? Alright, so how are we going to find x? There's two ways you can do this. If this is 26, then you can tell me what that angle is, or you can tell me what this angle is, and it doesn't matter which one you use in the problem. A lot of people like to use this one because there's no math involved. This is parallel to the bottom. That's a transversal. That makes these two angles, here and here, alternate interior angles. Therefore, if that angle is 26, then this one is 26 as well. Okay? Or, this is a 90-degree angle, so if you wanted to, you could subtract 90 minus 26 and give me that angle. It's up to you. I'm going to use this one. Okay? This one, we got 26 because it's an alternate interior angle. Alright, so I have a right triangle. We're going to use trig. Here is my theta, so that makes 3 my opposite side. So my opposite side is 3 kilometers. And my adjacent side is x. So that's going to be the tangent formula. Alright? So, tangent of theta equals O over A. So tangent of 26 equals 3 over x. When x is on bottom, you switch it. So x equals 3 divided by tangent of 26, which is equal to 6.15 kilometers. Oh, y'all can't see that. Sorry. Okay, so again, the opposite of the degree, here's my 26, the opposite is 3. The adjacent is x. So I use tangent. I plugged in, and when x is on bottom, you switch it. Okay? Next example. This is, I believe it's on the same page or the next page. It's the one before it. It's the quick check number 2. So it should be under example number 2. If you want to read along, you can get a book. Okay. Alright, this one's talking about a person on the ground. Okay. And there's a cliff that the person is climbing. There's a little tree up top. Okay. So we got somebody doing some cliff climbing up here. Okay. And you're down at the ground waiting for him to come down. It tells you that you are 1,000 feet away from him, and that the angle of elevation, there's your line from you to him, and the angle of elevation, notice I'm going from the horizontal up, is 32 degrees. They want to know how high is he on the cliff. Okay? So, again, this would be my adjacent leg. So my adjacent is 1,000, and my opposite is x. So again, we have tangent. Now you will have some questions in your homework that use sine and cosine. Oh, I'm sorry. I looked at my picture wrong. They want to know how far you are away from him, not how high he is on the cliff. So they want to know this distance, so that does make it something different. Alright, our adjacent is still 1,000, but now they're asking for the hypotenuse. Okay, so that's not going to be tangent anymore. Which one has the adjacent and the hypotenuse? That's cosine. Cosine of theta equals A over H. Alright, so cosine of 32 equals 1,000 over x. Go ahead and switch them. Divided by cosine of 32. And that's how far away you are from the person. Okay, so basically you're doing exactly what we did last week. A lot of y'all are starting to get a little bit more comfortable with it, so now we're going to apply it to real life situations and word problems.